Good evening, dear all. Today we shall do some numericals on electric dipole. I am Dhanu Saraiya and I will be teaching today the basics of how to find out the zero electrical intensity at the electric dipole and the other configurations where we will have different polarities of charges. So in the beginning, I will just start with the basic how to actually approach a numerical. So remain with me till the end of the whole video so that on the basis of electric dipole how different numericals can be approached and calculated, that will be understood by you. Fine. So let us first understand the first configuration in which we are considering a normal dipole with one positive charge and a negative charge. This is a normal dipole with one positive charge and negative charge of equal magnitude. Okay, now we are interested in finding out a point of zero intensity. Electrical intensity, if you say intensity, you say field intensity, you say everything is the same. Okay, so now let us consider a point. It's not at the center, at any point, say O. So how do I find out electric field at this point? Due to positive charge, as per the rule, positive charge to the point outwards. So let me name it as E1. Now as per the rule again, from the point to the negative charge due to negative Q. So let me name it as E2. So now what does it mean? That at the center or between the two charges, we are not going to get electric field intensity 0. I'll just put a cross here. Why? Because E1 and E2 both are in the same direction for a dipole with the same magnitude. So let me consider one point here. Now again I do the same thing. Electric field due to positive charge. How do I go? Positive charge to a point, say B. Let me name it as E1. This is due to positive charge. Now, from negative charge, I must go inwards. Okay. E2. So now, is there a possibility to get a zero intensity? Yes. Why? The directions of E1 and E2 are opposite. And if the magnitudes are same, yes. So there is a possibility of getting a zero intensity at the other side of the charge negative Q. Can I get same thing this side? Let me consider one point A here. I can consider A, B, C, 1, 2, whatever. So again positive charge as per the rule E1. Electric field due to negative charge as per the rule, I must go towards the charge E2. So do I have a possibility of getting a negative, a zero electric field here? Yes. Why? Because E1 and E2 are opposite to each other at this point. So I can get a zero electric field intensity at the point A and at the point B. Fine. Provided magnitudes of E1 and E2 are same because the directions are opposite. Between these two charges, I will not get. So what you should remember, if one charge is positive, other charge is negative, it is an electric dipole, then the possibility of getting a zero intensity electric field is this side of the dipole or that side of the dipole, not on the axis or between the two positive and the negative charges. Fine. Okay. Now here the magnitude was same. So you may think because magnitude is same, we will get it. But I can take another charge where magnitude is not the same. Not necessary that magnitude should be same. Let me say here it is plus. This I am giving just examples. Let me say it is negative 2Q here. What I am interested in, what should I take care of? Only the polarity, irrespective of whether the magnitudes are equal. Then where do I get the zero electric intensity? from this knowledge, where will I get? I will get it here. I can see E1, E2, opposite. Somewhere there. Or here. I can say this also again. E1, E2, opposite. Can I get it here? No. That means I will not get a zero electric intensity somewhere in between these two charges of different polarity. So when the numerical is thrown to you, first of all you have to identify whether it is a dipole or no. If yes, then where do I get the intensity 0? Where? Either this side of the dipole or that side of the dipole. Not in between the two charges. That should be in your mind. These small tips will be very useful for you when you actually do the numerical very fast. Understood? So now let us go to the next combination where I will take one as 4Q, another one as 2Q. Both are positive. What am I searching for? I am searching for a point where will I get the electric field intensity 0. So let us start here. Again following the same rule of finding out the direction of the electric field. If the electric field direction is opposite, definitely at that point I am going to get a 0. Okay, this is not the center. This is some point between the two positive charges. Fine. So let us start. So here as per the rule, I go like this for the electric field due to the positive charge 4Q. Here I go from here to the point in this way. So is there a possibility of getting a 0 here? Yes. Why? Because electric field are in opposite direction. I need not go to the other 2 points, but just for your satisfaction, let us see. Let me say this is the point B. Now due to this 4Q, as per the rule, outwards from 4Q. As per the rule again, outwards from 2Q. So is there a possibility of getting a 0 electric field intensity? No, because both E1 and E2 are in same direction. Same will happen here also. So needless to search where you are going to get the electric field intensity to 0 if at all both the charges are positive. Whether they have same magnitude or different magnitude like this. When two charges are positive, field intensity will be 0 only in somewhere between the two charges. Sure. Okay, so here we just stick for center so that in the last we understand summation. Okay, center in the sense that somewhere in between. Now let us take two charges negative. Again let us search somewhere here O. We just trying with our rule how to draw the electric field direction. Okay, so here how do I do? For minus 2Q I should go towards the charge electric field E1. This is the electric field due to negative 2Q at the point O. This from here where should I go? Towards that charge to get the electric field due to that charge. Okay, so here I got both E1 and E2 opposite. So will I get electric field intensity 0 at this point somewhere in between these two charges? Yes. So what is my conclusion? That if both are having the same polarity, that is both are negative or both are positive, definitely I will get electric field intensity, electric field answer 0 at a point somewhere in between the charges. Let me try here. Let me use one point here. What is my rule? Yes, due to this charge and due to this charge going towards the charge from the point. So this is say E1. This is say E2. Will I get electric field intensity 0 at the point B? No, because both the fields are in same direction. So what is the summation of this page which I am conducting? That if at all I have two opposite charges of opposite polarity, then my electric field intensity will be 0 at two ends, points at two ends. And for same polarity, intensity, field intensity E is equal to 0 here for a point somewhere in between. E is equal to 0 here for point somewhere in between. Why? Because here the directions are opposite. Here, what will I get? E is equal to 0. Here also E is equal to 0. Possibility. E is equal to 0. I can get. Why? Directions are opposite for E1 and E2. This is your remembrance for electric field intensity 0 points. For opposite polarity, same polarity. Because normally this question is asked, find the point, and child gets confused. Sometimes the point is between, sometimes the point is this side, sometimes the point is that side. No, just remember opposite polarity I will get intensity 0 at this side or that side. Same polarity I will get electric field intensity 0 where? Somewhere in between the two charges. Done. I am done. Fine. So using this technique, let us do a numerical where we find the electric field intensity 0. How to do it? Okay? Just take a picture. So remembering the concepts which we learned just now, let us solve a numerical where we have 2 point charges 4Q and Q separated by a distance 1 meter in air. A medium is air. At what point on the line joining the charges is the electric field intensity 0? This is the question. So now, because both are positive, their magnitudes are also different. Where do I find the electric field intensity 0 with our previous argument? Somewhere in between these two charges, let me say at O. Fine? Okay, so they are asking me where? O is not the midpoint. So let me consider OA is equal to X. So this much is equal to some X, which I am going to find out. Let me consider OB is equal to 1 minus X. So this much is 1 minus X. Why did I do this? Because for finding out electric field, I need the distance from the charge to the point. So I found out. Correct? So in that case, let me consider QA is equal to 4Q and QB is equal to Q. Fine? Okay. So now what should I do? I should find out the electric field direction at this point. I should do. I know it, but I should do. So what should I write here? EA. I can write it EAO also. Correct? So from charge, positive charge to the point outwards. Here from the positive charge to the point outwards. So E, BO. They both are opposite to each other. Correct? So what is my superposition principle? E at the point O is equal to EAO plus EBO. Correct? Fine. So let us find out the magnitude EAO and EBO. Fine? EAO from magnitude. EAO is equal to K. What is the charge for A? 4Q. And what is the distance for AO? X square. Again, magnitude EBO. What is the charge? Q at B. So I'll write here Q. What is the distance? 1 minus X, the whole square. Now I substitute these values here, remembering that the electric field is of opposite directions. So one of them I have to write it as negative. Fine? And one more thing I must remember, but they already gave me at some point electric field is 0. They gave me, so I will put that also. Okay? This is equal to 0. They gave me. I am searching that point. So now let me write as a magnitude k 4q upon x square minus k q upon 1 minus x square is equal to 0. I just see, for such questions you don't start solving all this directly. Just take minus term that side and then try to do the calculation and make things easier for you, nothing else. See, q cancel. So what am I left over with? 4 upon x square is equal to 1 upon 1 minus x square. Again, you can see this is of a square. Even if it is not of square, even if it would be 3, just take under root. It will be easier for us. So I get 2 upon x is equal to 1 upon 1 minus x. Fine. So now I just cross multiply. That is 2x. 2 minus 2x is equal to x. So 2 is equal to 3x. X is equal to 2 upon 3. So value of x is 2 upon 3 out of the 1 meter. And what is the another part? 1 minus x. So 1 minus 2 upon 3, that is equal to 1 upon 3. I can write even as a decimal form 0.66. And here x, that is the distance, is equal to 0.33 leftover part. So that the total of these two is 1. So what should your answer be? That at x is equal to 0.66 meter from A, the electric field intensity is 0. That should be my answer. Fine. Okay. So in this way, whether the polarities are same or different, we can find out the electric field intensity 0 at which point. Fine. Okay. Take a screenshot. I'll just move. So continuing our knowledge of how do we calculate the electric field at different points on two charges at one axis, let us continue with the numerical. 2-point charges QA is equal to 3 microcoulomb. I have written QA is equal to 3 microcoulomb. Remember, whenever there is micro, you must write 10 raised to minus 6 coulomb. Then QB is equal to negative 3 microcoulomb. So negative 3 into 10 raised to minus 6 coulomb. This is what is given to us. I have written here. Are located 20 centimeters apart in the vacuum, 20 centimeters apart in the vacuum, which I have broken into parts as 10 centimeter, 10 centimeter OA and OB. So whenever there is conversion, remember conversion should be written. So 10 into 10 raised to minus 2 meters that I have written. What is the electric field at the midpoint O of the line AB joining the two charges? That is the first part of the question. Okay, so now we must know the electric field at the midpoint. Because it is written midpoint, I have broken 20 centimeters into two parts. Now at the midpoint or at any point between the two charges of a dipole, this is the dipole, what should be the electric field? Intensity 0 or some value? Again, go back. It should not be 0. It cannot be 0. Somewhere at the between. So we have to calculate. So again, revising what we remember, plus Q, positive charge. So to the point EA, let me write. So this is the direction of electric field for the charge at A. Positive to the point, go outwards. This is negative. So from the point towards the charge. Am I right? EB. Correct? So by now you should be clear how to approach a numerical. First work is to find out the electric field direction at that particular point which is asked. I found out. Positive, go to the point outwards. Negative, point towards the charge. Both are in same direction, you can see. E and EB. So it is understood. I have to add it. Irrespective of the polarity, negative. Once you have decided the directions are same, I have to just add the magnitudes. That's it. That is what I am trying to say. Maximum children get confused in this. It is minus here, यहाँ पे तो minus है, फिर add के क्यों करना है? Why to add the electric field? Because the direction of the electric field at the point O due to these two charges is in same direction, so I should add their magnitudes. Done. So now it is very easy for me. I have drawn the electric field diagram and given is already written by me. So I have to just substitute. Fine. Okay. So I am just talking about the part 1 right now. Okay. So I go to the superposition principle. Theory is to be connected to the numerical. That is the only point here. EA plus EB. This is the superposition principle. You can also write to impress the examiner that you know why you are adding. Superposition principle. You can write, you have space. Because of this principle, I have added the electric field at this point. O, midpoint, they have told me. Fine. So E is equal to, now I find out what is EA and EB from the diagram. Okay. What is EA? Magnitude. K. Q. Q is 3 microcoulomb, so I will just write 3 into 10 raised to minus 6 coulomb upon distance square. What is distance? 10 into 10 raised to minus 2. However you are comfortable. You can even write it as 0.1. That also you can write. Okay. EB. Same. Irrespective of the negative symbol there. As I already told you, don't worry about the negative symbol. We have decided the directions. While writing, never use the negative symbol. The direction will decide whether I have to add here or subtract here. Direction is same, so I have to add here. So I will add. Okay. So what is my answer? K. 3 into 10 raised to minus 6 coulomb upon 10 into 10 raised to minus 2 whole square plus K 3 into 10 raised to minus 6 coulomb upon 10 into 10 raised to minus 2 whole square. Now you can see both are same. So I can just write 2 and I am also substituting K. K is 9 into 10 raised to 9. Revising the unit, Newton meter square per coulomb square, into 3 into 10 raised to minus 6 coulomb. I have written 2 here. Done. Divided by 10 into 10 raised to minus 2 whole square. So calculating this value and also writing down the direction is along OB, we have E is equal to, now for such calculations, as I already say, always 2 into 9 into 3. Whatever numbers are there, you write in the numerator and the denominator. So I can see 3 numbers, 2, 9 and 3. Okay, there is no square also. Multiplied by the power 10 raised to 9 into 10 raised to minus 6. No other power is available to me. Then down I go as 10 square, that is 100, into 10 raised to minus 2 whole square, that is minus 4. Okay, so solving this, what I get is, this is very important to write the direction. What I get is, electric field is equal to 5.4 into 10 raised to 6 Newton per coulomb. Direction along OB. Fine. This is my answer for the first part of the question. Clear? Okay. So take a screenshot so that we can go to the next part of the question. second bit. Fine. Okay. So continuing the same question for the same combination or configuration of charges, remembering that we have already calculated E is equal to 5.4 into 10 raised to 6 Newton per Coulomb, and the direction of this electric field was along OB, along OB. Now they have given us another part of the question where they have asked to put if a negative test charge of magnitude, negative test charge of magnitude 1.5 into 10 raised to minus 9 coulomb is placed at this point, same point. Okay. What is the force experienced by this test charge? So let us take the test charge as Q naught is equal to negative 1.5 into 10 raised to minus 9 coulomb. Negative it was, so I wrote negative value. I have written. Where is it placed? It is placed at the point O itself. That's why I have written Q naught is equal to Q naught is QO. Charge at O. Okay. Now they are asking me what is the force experienced there due to the other two charges QA and QB at the point O. Okay. So remembering that F is equal to EQ. Okay. This is another formula of electric field. If you remember, electric field is equal to F upon Q. So I have written F is equal to EQ. I will write here F naught. Okay. E we just now found out at the point O. So I can write this as E naught also. I just substitute these values here from what is given to me, that 5.4 into 10 raised to 6 multiplied, I can even write the unit here, multiplied by the charge is negative, so that negative symbol I will put here, into 1.5 into 10 raised to minus 9 coulomb. So now here again, as explained earlier, separate the numbers and the powers so that it is easier for you to calculate. Newtons, F naught. And what is the direction? Direction of the electric field is always along the direction of the force itself. So direction of the force and direction of electric field should be same. So F naught should be along E naught. So what should I write? Along E naught. So I can write it from A to B. Along AB. Fine, because I have to mention the force of QA on QB. So I have written A to B, otherwise it is OB for electric field. Direction is the same, whether I write OB or whether I write AB. Fine. So calculating this value, I get negative 8.1 into 10 raised to minus 3 newtons is the force at the point O along AB direction. Fine. So in this way you can have a combined question also, where they are asking you electric field also and they are asking you force also at the same point. So many varieties of questions are there, but one by one with the same logic you have to go ahead. Okay, so take a screenshot so that we move to another section. Fine. Okay, so now we move to another question. Read the question properly and understand it and draw. I have already drawn, but I will make you understand how to draw it. Our system have two charges, QA positive 2.5 into 10 raised to minus 7 coulomb, QB negative 2.5 into 10 raised to minus 7, which I have noted as plus and minus QA cube. Okay. Now located at the point A. Now A is given as the coordinate system of XYZ plane. B is also given like that only. So whether they give us positive or negative, it means negative is this side of O. We can take it as the origin and positive is that side. So we have to just write the magnitude 15 centimeters here, 15 centimeters there. Be very careful of doing that. Okay, so minus 15 centimeters I have written this side of the origin, plus 15 centimeters I have written that side of the origin for the point B. Okay, now what are the total charge and electric dipole moment of system? Now these two charges are having the same value. One is positive and one is negative, so it is a dipole definitely. For a dipole, immediately connect the theory. For a dipole, the theory says that net charge, total charge of the system is 0. So just write the charge, total charge is 0. Fine. So first bit I can write total charge equal 0. If you want, you can show also QA plus QB is equal to 2.5 into 10 raised to minus 7 coulomb plus negative 2.5 into 10 raised to minus 7 coulomb, which amounts to 0. So always for a dipole, the net charge is 0, which is shown here. So this can be one multiple choice question also, which you have to remember as a part of theory and numerical. Now next part they are asking me electric dipole moment of the system. What is the formula for electric dipole moment? What is the formula? P arrow is equal to Q into 2A P cap. So what is our Q? One of it. That is written here. What is our Q? 2A, distance between the two charges, that is 30 centimeters. That is also written here. Just substitute. So Q is equal to 2.5 into 10 raised to minus 7 multiplied by the distance is 30 into 10 raised to minus 2 meters. Remember, conversion factor is there. Fine. So as usual, just separate the numbers and the powers, and the answer we get is coulomb meter. So we calculate it as, from here we get 75 into 10 raised to minus 9 coulomb meter, or 7.5 into 10 raised to minus 8 coulomb meter. Remember to write the C little bit bigger, along what is the direction of the dipole? Negative to positive. So along B A. Fine. That is from B to A. That is the direction which they haven't asked us, but they asked us to calculate the dipole moment which I have written. Fine. So take a screenshot. This is a simple question, but looking at it, you may have how to solve it, but quickly you can do it with your theory knowledge itself. Fine.